In the world of industrial processing and water treatment, there is one silent giant that does the heavy lifting: the clarifier. Whether it's the water coming out of your tap or the effluent from a massive factory, clarifiers are the unsung heroes of separation. But how do they turn murky, debris-filled liquid into crystal-clear water using nothing but gravity? At its core, a clarifier is a settling tank built to remove solid particulates or suspended solids from a liquid. Unlike a filter that screens particles out, a clarifier relies on sedimentation. Heavier solids, known as sludge, sink to the bottom. While lighter materials, or scum, float to the top. This leaves a clarified liquid in the middle. To understand how it works, let's look at the anatomy. A standard circular clarifier has 7 main components. Influent pipe. This is where the dirty water enters. Energy Dissipating Inlet. This is the heart of the entry system. Think of the EDI as a brake for the water. Feed well. Surrounding the EDI, this large cylinder further directs the flow downward and creates a quiet zone for flocks to grow. The scraper arm, a rotating set of blades at the bottom that slowly pushes settled sludge toward a central hopper. Weirs and effluent launder. These are the notches at the top edge. They ensure the clean water overflows evenly without creating suction points. Skimmer and scum baffle. These catch floating oils or grease before they can exit with the clean water. Drive unit, the motor that keeps the scraper arm turning at a very slow and precise speed. Physics plays the biggest role here. We use something called Stokes' law to calculate how fast a particle will fall. Don't let the math scare you. Essentially, it means that the speed of settling depends on the particle size and the difference in density between the particle and the water. In many cases, the particles are too light to sink on their own. That's when we add coagulants or flocculants, chemicals that make small particles clump together into flocks, so they become heavy enough to sink. There are 3 types of clarifiers. Circular clarifier, best for large-scale municipal water, and it's a most common. Rectangular clarifier, best for space-constrained plants, uses a flight and chain system. Lamella clarifier, high-speed settling in a tiny footprint. We will cover the rectangular and lamella clarifier in the other videos. Running a clarifier isn't set it and forget it. Operators must monitor, checking the sludge blanket depth. If it gets too high, solids will carry over into the clean water. If the rake hits a massive clump of sludge, the motor can burn out. If the water moves too fast in one direction, it ruins the settling efficiency. From treating the water we drink to protecting our oceans from industrial waste, the clarifier is a masterpiece of mechanical and chemical engineering. If you found this deep dive helpful, hit that like button and subscribe to Mechanim for more breakdowns of the machinery that powers our world. What machine should we cover next? Let us know in the comments below. I'll see you in the next one.